Good morning and welcome to Algebra 1 Honors. Today we're going to continue reviewing for what will be your Unit 1 test. On the board again are the topics of the day. So let's not forget, we have to go over properties that allow us to solve problems, the proofs where we demonstrate our knowledge of those properties, how we solve equations, which you've been doing for a while now, special cases, which include all real solutions, which is infinite solutions, or no solution if the problem has no answer. Clearing fractions. In order to get a fraction to go away, we multiply by the denominator of the fraction. The noise is my cat, just so you know. We got proportions with cross products and how we solve those. And we also have simple and compound inequalities, graphs of those inequalities, absolute value equations, and absolute value inequalities. And to prove that I was not lying, here's the cat. Here's the offending kitty. Say hi, Molly. Yep, she doesn't say much. She doesn't like talking. Okay, so what I'm going to do now is erase this and just go through a couple of examples which will allow us to hopefully review a little bit. Also, the test is going to be over 2 days, Thursday and Friday. And on both days, whether or not you are in school or at home, there will be a portion of the test to complete and submit. So please be aware of that as well. Now, let's do an example or two. Let's try this one, ready? Here's a proof. So here's the problem. -2 parentheses x minus 3 equals x. Let's solve this one as though it were a proof, just like we had in the first quiz. Pause the video, solve the problem, play the video to check the answer. Do that now. Let's solve it. First thing I want to do is I'm going to distribute the 2, the -2. So -2x plus 6 equals x. And because it's a proof, we have to give the reason that allowed us to do that. That's the distributive property. Now, because we did not distribute to both sides of the equation, it's not a property of equality, it's just a property. I have -2x plus 6 equals x. I have an x on both sides of this equation, which I don't really want. So I'm going to add 2x to both sides. And that gives me 6 equals 3x. Because I added 2x to both sides, that's the addition property of equality. So we call it addition property of equality. And I'm going to abbreviate property of equality as POE. It's faster. And I also have 3x here, but I don't want 3x. And how do we cancel out a coefficient? Well, we divide both sides by that number. And we have 2 equals x, or x equals 2, whichever way you like. I divided by 3 on both sides, so the answer to the reason there is the division property of equality. Now, those are 3 of the 6 properties. Don't forget that so far as properties of equality go, we could have subtracted from both sides. That would be the subtraction property of equality. We could have multiplied on both sides to clear a fraction. That would be the multiplication property of equality. We also could have combined 2 like terms that were on the same side of the equation, and that would be combining like terms. That's it. Okay, that's our proof. Let's move on. And the next question will be a proportion. So solve this proportion. We have 2x over 3 equals 4 over 5. Okay, as before, pause, solve, and then play the explanation. Do that now. We solve a proportion by cross multiplying, also called cross products, which basically means we're going to multiply on a diagonal. 2x times 5, that's 10x, equals the other diagonal, the 4 times 3, that's 12. Now I have 10x, but of course I'm solving for x. So I divide by the coefficient, which is 10, and I get that x is, you could say 1.2, it's fine. You could also have reduced the fraction to 6 over 5. That's fine too. Or 1 and 1/5. That's also fine. But that's the answer. And that's proportions. Okay, let's try a literal equation. 4xy over 3 plus 2 equals 10. Solve it for x. All right, so again, pause, solve, and play, go. How do we solve the problem? Well, I'm trying to get x by itself. So the first thing I want to remove is that plus 2. I'm going to subtract 2 from both sides. I get 4xy over 3 equals 8. Well, the fraction's kind of getting in my way, so I can clear the fraction by multiplying both sides by the denominator, which is 3. So we're including clearing the fraction here. This 3 cancels the denominator, so it's 4xy, but it, of course, does multiply the 8, which is 24. Okay, I'm going to divide by 4 because I'm trying to get x by itself, and that's a good place to begin. So that means xy equals 6. Last thing I have to do is get rid of the y, and again, it's a multiple, so I'm going to divide by it. Divide by y, and x equals 6 divided by y. It's called a literal equation because it involves multiple variables. All we did was we unfolded the problem to get x by itself. Next, we have, let's see, let's go with a compound inequality. There's more than one variety, but I'm not going to do every problem under the sun today. This is just a best of. So here's what I want you to do again. Big surprise. Pause, solve it, play the video, go. How do we solve a compound inequality that is between two other inequality symbols? Well, we're still trying to get the x by itself. It says 4x minus 2 in that section in the center. I want to get x by itself, so I'm going to get rid of that minus 2 by adding 2 to each one of these sections to keep it all in balance. So 10 plus 2 is 12, which is less than or equal to 4x, which is less than 22 plus 2, which is 24. All right, well, I got 4x, but I want to get x by itself, so divide everything by the coefficient of 4. Again, not just in the middle, but on both of the outer edges too. 12 divided by 4 is 3, which is less than or equal to x, which is less than 24 divided by 4, which is 6. We've solved the problem, and then we're going to have to graph the inequality because we're graphing all of our inequality solutions. So I'm going to put it over here. Number line, I have two anchor points. They are 3 and 6. The symbol for 3 was a closed dot, and the symbol for 6 is an open dot. X is in between the two values. It's more than 3, but less than 6. It's going to connect those two dots. No arrowheads required. That's the solution to that one. When you get a solution that connects like that, it's called an intersection. Also could have used the word and, because 4x minus 2 was greater than or equal to 10 and less than 22. Okay. Well, after we covered inequalities, we moved on to absolute value. We solved absolute value equations as well as inequalities. I'll give you an inequality problem for absolute value right now. 4 minus 2 absolute value, 3x plus 1 is less than or equal to negative 12. As is the custom now, pause the video, solve the problem, play the answer, go. Please don't ever subtract the 4 minus 2. Don't do that. The 2 is being bound to the absolute value by its proximity. It's being multiplied against that absolute value. So we can't just say 4 minus 2 is 2 and go on from there. Please don't. But I will begin by removing the 4. That 4 is a positive number, so I'm going to subtract it from both sides. And I get negative 2 absolute value 3x plus 1 is less than or equal to negative 16. Before you get all worried about an absolute value having a negative solution, please again remember, we're not there yet. We're not splitting it yet. We still have that negative 2 to worry about. Again, never distribute into absolute value. It's much better to, instead of multiplying, divide by negative 2 to remove it from this side. If I divide by the negative 2, it cancels out. But of course, both sides have to get divided by negative 2. So we have absolute value of 3x plus 1 is greater than or equal, because we divided by a negative, it's still an inequality, it still follows those rules, positive 8. Okay, well now our absolute value is yielding a positive solution, which is what we want. And we had to remember to flip that symbol because you divided by a negative. Now I can break it into 2 different problems. One where 3x plus 1 is greater than or equal to 8. Or the other where 3x plus 1 is less than or equal to negative 8. Remember that when you make that second problem, you reverse the inequality symbol and you make the result negative. And we subtract 1 from both sides. 3x is greater than or equal to 7. Divide by 3. X is greater than or equal to, keep it at 7/3. Over here, we'll subtract 1 from both sides. 3x is less than or equal to negative 9. X is less than or equal to negative 3. So I have a number line graph with negative 3 on one side and 7/3 on the other. The 7/3 is a closed dot. It says greater than or equal, it goes to the right. The negative 3 is a closed dot. It says less than or equal, it goes to the left. And we're done. We're done not just with the problem, but we're done with our review for the day. Those problems constitute the vast majority of the material we covered. Obviously, there's different varieties that we can cover, but that's it for today. What I want you to do, not so much a homework assignment, but what I'd like you to do is go over the things we've been doing and tell me what you want more help with. It's going to help us with tomorrow's lesson and review if you tell me what is difficult or at least a question you have. It doesn't have to be a challenge. It's just something you want more clarity with. If there's nothing and you're perfectly good and ready to go, that's fine too. Please join us for the Google Meets, which are going to be live streamed from class for the rest of the week. And let me know if you have any questions. Otherwise, that's all for today. Have a good day.